everyone and welcome to my new video. What is this video about? Well, I'm going to explore some texture feedback processing in Max using some jit.gl.pix gen programming stuff to create like a sort of custom shader to apply distortion to a feedback of a texture. Before I do that, I strongly recommend that you go and watch this video by Hearing Glass, a very good Max YouTuber, and this is some very good stuff. I'm basically going to steal this idea, particularly this bit down here, because the results are very good. But I'm just going to all this stuff over here I'm going to do slightly differently, but these are some great videos. In fact, the channel is very good. Go and listen to it. In fact, there's a comment there from me. Look, going to try this. I'm doing that right now. I'm literally doing that right now. How about that? So go and watch that. I'll put a link in the description. Anyway, so let's get started. I've got a picture here of my logo, or one of them, and I'm going to run this into a feedback network and kind of mangle it and sort of make it go all swirly and weird, and in a very experimental fashion, writing like a sort of experimental procedural shader to apply the distortion. So this is an FPIC object. I've dragged in literally just dragged that picture in, and it creates this thing called an FPIC object. When you download this patch later, you will need to drag in your own picture in order to do this. So to start with, I'm going to put this into a jit.gl.pix. Whoops, .pix. Let's zoom in a little bit. And I'm going to steal now the part from the Hearing Glass video, which is, I mean, I've actually kind of, I think I maybe already made a snippet here. Did I make a snippet? Text feed. Yes, I did. Okay, slightly differently. Okay, let's use this then. So this is a snippet I made. And there's a pix thing here. Okay, I'm not actually, yeah, I don't actually want any of this. So actually, I'm going to delete that and just reload this. Maybe it'll reload it empty. No. Okay, that's fine. Actually, I'll just trash all of this and put that in there for now because I want to do it all from scratch. Right, so basically what's going to happen is that I'm going to send the output of this FPIC into the cold inlet of the ZL reg, which is basically just going to store the contents. ZL objects work with lists, and textures and matrices are essentially lists as well. So I'm going to connect my render bank to this. And then it's not actually going to send that data out until I send a bang into this inlet here. So I'll make a bang here. And then what's going to happen is that the contents of that texture is going to go out into this jit.gl.pix, out into this other ZL reg object, into this texture, and then back in again to create a feedback loop. And in order to do that continuously, we can bang this one here. This is all stuff from the Hearing Glass video. Very, very good results. So I'm going to make a jit.gl.video plane at transform reset 2, connect the output, let's maybe move some of this along a little bit, connect the output of that to the video plane. And then when I bang this, bang, it's now on the screen on our video. And we're not seeing any texture sort of feedback processing yet because we haven't applied any. But essentially, this is being constantly fed back round and round and round and round. Okay, so for example, if I was to maybe, I don't know, do like a jit.noise, float 32, let's say 100 by 100. Let's see if this works. Plug that in. Probably nothing will happen because I haven't actually done an algorithm here. Let's do plus. See what we get. Ah! So yeah, I mean, it's obviously bled. It's fed back so much that it's just kind of bled to red, which isn't good enough. So actually what I'm going to do is I'm going to start in here. I'm going to make a sample, connect the input of the pix to the sample, and then I'm going to make a norm to get the normalized coordinates of this input. And I'm going to add that to whatever I send into input 2 and sample it. I'll do that in a minute. We'll come back to that shortly. So let's move all this over here. what I'm going to do now is I'm going to write my own little custom shader. I'm going to make jit.gl.texture. And let's give it the same dims as the image, which is 1080p. So let's say appdim 1920 by 1080. And then bang that with our render bang. Maybe make that look a bit neater. And these ones too. Neaten it up a bit. Right. So what we'll get is we'll get that as an empty texture, or my bathroom floor. So I'm now going to make a jit.gl.pix. Plug the texture into that, and then I'm going to write my own sort of algorithm, my own sort of shader, I suppose. So let's go into this. I wonder if I can get this all to fit on the screen. Okay, so I've moved everything around a little bit just to so that we can see what we're doing. Right, so to start with, so this here, over here, this is the contents of this jit.gl.pix. I'm going to write my own shader in it. I'm going to start by getting the normalized coordinates of the input texture, which is currently empty. And let's just see what we get on the way out. Yeah, so we have 0 to 1 on the x-axis and 0 to, x-axis and 0 to 1 on the y-axis, starting here. So that will go from 0 to red, RGB, 0 to red and 0 to green on the Y, and then ultimately end with yellow over here because they combine together. But if I was to swizz, let's go in here, swizz the X, not the Z. Oh, sorry, swizz the X. There we go. Right. So I have now swizzed only the X coordinate. So we can see that we're going from 0 to 1 on the X axis. We're getting black to white, 0 to 1. Now, if I apply a cosine and let's zoom in a little bit and multiply this by 10. Look at that. We've got some lines. So I'm going to make a parameter. I'm going to make a param, and I'm going to call this freak X to multiply the frequency of the X-axis going into this cosine. Okay, and then from over here, I can right-click and I can find my freak X there. There's my parameter I've just made. So if I increase this, oh, hang on. No, we need to go in here first. So let's say multiply by freak X. Whoops, freak X. Right. So now from out here, if I increase this, then I'm going to get more lines. Woo, yeah. So I've got some lines there. So already, if I was to plug that in to here, go in here. So I'm going to now simply add that to the normalized coordinates of this input texture, which is being sampled by the by input 2, I think. So let's bang that. Look at what's happened. Some stuff. I've mangled my logo, and if I do it more, you can see how we're getting this kind of constant feedback thing. Now, yeah, there we go. So this is a little bit aggressive. So let's go back into this one and maybe multiply this by a param, which I'll call scale. Yeah, or maybe AMT. And let's make a param, AMT. Let's come out of here. Let's go here. Let's right click the inlet and find our parameter AMT. And then let's give it a really, really small number. In fact, just to make this easier, let's maybe take an integer here and divide it by something like 100. And then I can just sort of type in 1 and I'll get a very small number. Right, so now we're getting some feedback that's not quite so aggressive. Yeah, so every time I bang this button here, I'm essentially restarting the feedback network. And then the distortion applied to the feedback is coming from our own little shader, which we're writing here. So maybe I could even divide that by even more. Let's divide it by 1,000. We'll get a really small number. Yeah, so we're starting to get these very subtle sort of bleeding pixels. Very nice. Data moshy, pixel shifty stuff. I don't entirely know the vernacular. They're just words I see on the internet. And I think, oh, that's what it is. There we go. Look at that. Looks cool, right? So let's carry on. Let's take, let's put this here. Let's take a copy of this and swizz the Y coordinates. Do exactly the same thing, but with the Y axis. And I'll make a param here for freak Y. Take that. And let's pack them together into a vector 0, 0. And see what we get. Right. Let's come out of here. Let's make this a bit smaller. And let's look for freak Y, our new parameter we've just made. Right. So now what we're going to get is we're going to get streaky lines on the Y-axis, which is, you know, giving us green. So, yeah, we've kind of got two parameters to play with there. Let's see what that looks like when we apply it to the feedback network. Whoa, yeah. Okay. You can see what's going on here. I can maybe make it more severe. Okay, very nice. But it doesn't end there. Let's keep going. So what I might do is apply a offsetting parameter before it hits the cosine. So let's make a param, whoops, why is it all the way over there? I can't delete you. Right, param, let's say time X. And let's do one for Y, time, oh my goodness me, time Y. And we'll go plus time X. And we'll go plus time Y. Right, let's go back out here. Let's find our time X and time Y parameters. And then we can simply apply jit.time so that that can just count automatically. Let's see what we get. Wow! Interesting. Let's increase the frequency. Ooh, yeah, it's pretty cool. I like it. Let's maybe try a smaller amount. Nice. Okay, so we're getting some crazy feedback stuff. I'm just going to go in here. I'm just going to try something. I'm going to try minus 0.5. See what that gives us. Oh yeah, that's a little bit better. So I'm going to apply a metro here. I'm going to say metro, let's say 3 seconds at active 1. So I can just leave that banging in the background whilst I play around. Let's try a slightly lower frequency on. That looks kind of cool by itself. But yeah. Yeah. All right. Let's try some other stuff. Let's get a little bit hacky. Let's just experiment. So why don't we just like maybe add? Let's do a sine on this one, cosine on the other one, and then let's just maybe add that one to that one and see what happens. And do the same here. Oh, look at that. Yeah, so you can see the results. It's pretty satisfying. I feel like a real computer programmer. Oh, there we go. Look. Yeah. And then as we increase the amount, and we can kind of rock it back and forth as well by increasing and decreasing the amount into the positive and negative. Yeah. I get so excited I forget how to talk properly. Let's try a lower frequency. Oh, it's exciting. Yeah. What else could we do? Well, we could, I don't know. Why don't we reflect this by the, I don't know, by the time of Y, and do the same here. Reflect this by the time of X. You can just sort of mess around, really. Like, nothing's going to break. Let's increase the frequency. It's interesting sort of looking at the output of this bizarre algorithm, which I'm making up as I go. Yeah. The other day when I was practicing this, I was getting it to go all swirly. And now it's kind of a little bit edgy. Excuse me. I can't remember how I did that. Damn. I wonder if we just put another cosine in here, maybe. No. Let's maybe bring this down to a really small number. Well, I mean, that's giving us sort of lots of noise, which is pretty cool. But actually, that's not what I want. Let's delete those. Let's maybe just stick a sphere. No, let's try sphere in here. No. Let's try sphere here. No, not much. Okay, I've ruined it. I've ruined everything. Okay, I'm actually just going to delete these. Put these back in here. We could maybe do like a kind of comparison or greater than, let's say greater than 0.5. Oh, that's interesting. Yeah. Nice. Yeah, that's looking very data moshy to me. Yeah. Sometimes I just kind of think I don't really know what to say. I just want to kind of look at it. Just sort of look at it do its thing. That actually didn't quite give me the result I was expecting, but I like it anyway. That's Max for you. Okay, that's a little bit more like what I was expecting, a hard edge. Let me put this in here. Woo. So now we're going to get the one of the axes is kind of gone. Let's maybe take this one out, put this one up here. No. What about here? Ah, okay. That's interesting. What about here? No. It's very experimental, but that's why I like it. You find things eventually and you kind of go, oh, that's kind of experimental art, isn't it? You sort of prat about until something nice happens. And then you pretend you did it on purpose. Or not. Perhaps I was being a tad facetious. Yeah, I wonder if we could change the cosine for a sphere. Ooh, yeah, okay, let's do that for this one. Let's change this one for a circle. Oh, just some lines. Let's change this one for a sphere as well then. Ah, look at that. Interesting stuff. They just look like pretty cool patterns by themselves, really. What would if we do like a fold? Fold 0 to 1. Interesting. Let's maybe put the fold here. No, let's put it back down here. Interesting stuff. Let's set these to have slightly different times. Let's say at speed 1, and this one can be at speed 0.75. We're going at slightly different speeds. Yeah. Cool stuff. All right, I think that'll do for now. So let's just do a quick recap. What did we do? We imported a picture. We're banging that picture with the render bang into this ZL reg, which stores temporarily the contents of that as a list, which then gets banged out by this bang here into this jit.gl.pix, which comes out into another ZL reg, which is being banged constantly at frame rate into this texture, and then back in again to create a feedback loop. And then inside there, we are sampling that along with the normalized coordinates of that input and adding them to this shader, which we've made over here with some parameters that we can kind of play around with. Okay, there you go. I enjoy this stuff very much. I find it very relaxing. It's like taking a bath in pixels. Going for a little paddle. Right, I'm going to go and put this on my Patreon now, where you can download that, sign up and download Max patches, Ableton stuff, whatever. And it all goes towards my research and development for making these bizarre videos. It's looking very interesting now. Yeah, very good for sort of making, you know, like when you sort of like drop oil on water. And it kind of, well, I don't know what that's like. I've never done it, but I've seen videos and I think it's sort of a bit like that, you know. Cool. All right, nice one. Join Patreon, download the stuff, or just copy what I've done in here. Have a nice time. Cheers, bye.